Very good evening, my dear second semester, all branches. Now, uh, this is the dynamics is the one of the important portions of the engineering mechanics. First of all, what is elasticity? If the balls of different materials are allowed to fall on a marble floor, they will rebound to different heights. This property of bodies, by virtue of which they rebound after impact, is called elasticity. Generally, a body which rebounds to a greater height is said to be more elastic than that which rebounds to a lesser height. What is inelastic bodies? If a body does not rebound at all after its impact, it is called an inelastic bodies. Then I will discuss what is law of conservation of momentum. It states that the total momentum of two bodies remains constant after their collision or any other mutual action. Mathematically, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, where m1 is equal to mass of the first body, u1 is equal to initial velocity of the first body, v1 is equal to final velocity of the first body. Then m2, u2, v2 are the corresponding values of second body. Then what is Newton's law of collision or of elastic bodies? It states that when two moving bodies collide with each other, their velocity of separation bears a constant ratio to their velocity of approach. Mathematically, v2 minus v1 is equal to e within bracket u1 minus u2, where v1 is equal to final velocity of the first body, u1 is equal to initial velocity of the first body, v2, u2 are the corresponding values for the second body, and e is equal to constant of proportionality. What is coefficient of restitutions? It is very one important short question. According to Newton's law of collision of elastic body, v2 minus v1 is directly proportional to u1 minus u2, where v2 minus v1 is equal to e within bracket u1 minus u2, where v2 minus v1 is equal to velocity of separation, u1 and u2 velocity of approach, where e is equal to, it is a constant of proportionality known as coefficient of restitutions. The value of e lies between 0 and 1. If e is equal to 0, it indicates that the two bodies are inelastic. If e is equal to 1, it indicates that two bodies are perfectly elastic. Suppose define collision. The term collision means the interaction or the contact between two bodies for a short period of time. Now I will discuss one important problem. First question, a ball of mass 1 kg moving with a velocity of 2 meter per second impinges directly on a ball of mass 2 kg at rest. The first ball after impinging comes to rest. Find the velocity of the second ball after the impact and the coefficient of restitutions. First of all, data given. m1 is equal to mass of first ball is equal to 1 kg. u1 is equal to initial velocity of first ball is equal to 2 meter per second. m2 is equal to mass of second ball is equal to 2 kg. u2 is equal to initial velocity of second ball, that is 0, because it is at rest. Let v1 is equal to final velocity of first ball after impact is equal to 0, because it comes to rest. Velocity of a second ball after impact. Let v2 is equal to velocity of a second ball after impact. We know from law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here m1 is equal to 1, u1 is equal to 2 plus m2 is equal to 2 into 0 is equal to 1 into 0 plus 2 into v2, or m 2 plus 0 is equal to 0 plus 2 V2. Therefore, V2 is equal to 2 by 2 is equal to 1 meter per second, because the unit of velocity is equal to meter per second. Coefficient of restitutions. Let E is equal to coefficient of restitution. We know from the law of collision of elastic body, we have V2 minus V1 is equal to E within bracket E1 minus E2. Putting all the values, we have 1 minus 0 is equal to E, 2 minus 0, or 1 is equal to 2E, or E is equal to 1 by 2 is equal to 0.5. Now, I will discuss another problem. A ball of mass 2 kg moving with a velocity of 2 meter per second hits another ball of mass 4 kg at rest. After the impact, the first ball comes to rest. Calculate the velocity of the second ball after the impact and the coefficient of restitutions. Data given. M1 is equal to mass of first ball is equal to 2 kg. U1 initial velocity is equal to 2 meter per second. M2 mass of second ball is equal to 4 kg. U2 is equal to initial velocity of a second ball is equal to 0, because it is at rest. V1 is equal to final velocity of the first ball after impact. V1 is equal to 0, because it comes to rest. Let V2 is equal to velocity of the second ball after impact. We know from the law of conservation of momentum, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Putting all the values, we have 2 into 2 plus 4 into 0 is equal to 2 into 0 plus 4 into V2. Therefore, 2 into 2 4, this is 0, is equal to 0 plus 4 V2. Therefore, V2 is equal to 4 by 4 is equal to 1 meter per second. Let E is equal to coefficient of restitution. We know from the law of conservation, collision of elastic bodies, we have V2 minus V1 is equal to E within bracket U1 minus U2. Putting all the values, we have 1 minus 0 is equal to E within bracket 2 minus 0, or 1 is equal to 2E is equal to E is equal to 1 by 2 is equal to 0.5. Therefore, E is equal to 0.5. Now, for your law of conservation of a linear momentum and Newton's laws of motion. These are very important questions for your semester examination. Kindly see my notes.